Welcome everyone, this is Noah, and we're going to look at solving equations and inequalities graphically using Geogebra. So we've got these two functions here in this first example. We have let w of x equals 1/4 x squared minus 3x minus 8. And we have the function m of x equals x plus 12. We're going to use Geogebra to help us determine the following questions. First, we want to find the points of intersection of the two functions. We're going to solve w of x equals m of x. We're going to solve w of x is greater than m of x. And we're going to solve w of x is less than or equal to m of x. So let's pull up the graphing calculator, Geogebra, and start by just entering in these functions. I'm going to go ahead and delete what I had in there first using those triple buttons. The first function I want to enter here is w of x equals 1/4. I'm going to use the right out arrow to get out of the denominator. X caret to the second minus 3x minus 8. Hit enter. We're going to have to change our viewing window here in a second. Let's get the other function in as well before we do any of that though. We have m of x equals x plus 12. Hit enter there. And now let's go ahead and zoom out on this. Alright, we've got all sorts of things going on here. I'm squeezing that. We're just zooming in quite a bit. Looks like these y values are way too big. There we go, that looks better. All right, a key thing that we want to see on this is the intersections of the two graphs. So I'm going to do one thing that we didn't do in the last one. I'm going to go ahead and type in the points of intersection that we see here. So we have negative 4.1655. Comma. To know what that was again, and then it gets mad at me, changes it from a point. This is going to be a little bit of a thing that happens sometimes. That second value is 7.834. 834. You might write it down just to help yourself, and then we got that x value was negative 4.1655. And then I can delete this, and I've got that point. I can right-click on that point. Or I'm sorry, just click on that point. Click the AA. Instead of showing the label, we can show the value, and that will keep that point in position for us. And let's actually do this a little bit better. Let's delete this, start over. I'm going to say intersect. I'm going to do W and M. And it shows both of these points. So I can say intersect the two functions above, and it will automatically show their intersections. And we can show their values instead of just the A and the B, right? All right, we've got these. It's really all we need for this problem. So I'm going to go ahead and take a screenshot of that. Just need these intersection points. So I'll take that and then paste that in here. Go all the way up. There we go. Zoom back in. Here. There we go. Okay. So it starts by saying, what are the points of intersection of the function? So we've got, we'll just do approximations of this, negative 4.166, right? That 5 rounds up to a 6, comma 7.834. And then our second intersection is at 20.166, comma 32.1 2c.6. All right, so we're going to start by solving w of x equals m of x. Remember, a solution to an equation is the x value where the outputs of both functions are the same, right? We want the w of x to equal m of x. We want the output of w to equal the output of m. At the x value. And so we see that that happens at the intersection points. When x equals negative 4.1655, etc., then both w and m output the 7.83447, etc. So we can say the solution set is, and we'll put in that negative 4.166, and then we also see then when x is 20.1655, then both functions output the same value, 32.1655. So those x values are the solutions to this equation. The next question says to solve w of x is greater than m of x. So w of x is the parabola, that's the blue line. And m of x is the red line. So we want the blue line to be above the red line. So we see that out here, to the left of the first intersection point and to the right of the second intersection point, we have w is above m. W is above m in these two sections. So if x is less than negative 4.166 or x is greater than 20.1655, then we have the blue line above the red line. We have w of x greater than m of x. So I'll then state the interval of solutions is negative infinity up to negative 4.166 along with, unioned with, 20.1655 all the way up to infinity. Next, we want to solve when w of x is less than or equal to m of x. So we want the blue line to be underneath the red line. And we can see that that happens. Let's change our highlighter color to green. You can see that that happens in here. This is where, and we can actually include the endpoints because we can allow them to be equal. So in this green area, we have w is greater than or equal to m. Right? The outputs of w are bigger than or equal to the outputs of m. And the x values where that occurs is when x is between negative 4.1655 and 20.1655. So the interval of solutions is, and use hard brackets now, negative 4.1655 all the way up to 20.1655. Close our square brackets, and that's it. We're good. All right, take your time. Make sure you've got that worked out. Pause the video if you need to. Let's move on to doing this in a little bit more abstract of a situation where we're just given an equation or an inequality, and we want to use GeoGebra to help us solve these equations and inequalities. So our first one we have is negative 2x cubed plus 5x equals negative 4x plus 16. What we want to do for this is we're going to let f of x equal one side. We'll go with the left side, negative 2x cubed plus 5x. And g of x equal the right side, negative 4x plus 16. And then we're going to graph both of those. So I'll pull the graphing calculator back up. And let's just start fresh here. Leave that. Start a new one. And then we want to type in f of x equals negative 2x to the third plus 5x. And then g of x equals negative 4x plus 16. Now we want to zoom until we can find a nice viewing window that shows their intersection or multiple intersections if that's the case. And we can see if I zoom like this, that we just have that one intersection right there. So I can take a screenshot there. And plot that in. Come on. I want to shrink it. I want to let me. There we go. So we graph both the left side and right side as their own functions, and then we look for that intersection. And then we know that when x equals, let's make this a bit smaller. When x equal, or is approximately, I'll say, negative 2.7266, both f of x and g of x output 26.906 approximately. So that's when the left and right side of the original equation, negative 2x cubed plus 5x equals negative 4x plus 16, when those two things are equal. So that means that negative 2.7266 is our approximation of the solution. So we can say the solution set is, I'll use set builder notation, the set containing the x values such that x is approximately, this allows me to keep that approximate symbol in there, negative 2.7266. Right? So we want to do this one more time for this next inequality, part B, where we have negative x squared plus 3x minus 7 is greater than 12. So we'll go ahead and get rid of these functions here. And, oh, I want to real quick write, let f of x equal negative x squared plus 3x minus 7, and g of x equal 12. Now we'll go ahead and plug those in. F of x equals negative x to the second plus 3, oops, got a right arrow out of that exponent, plus 3x minus 7, and then g of x just equals the constant horizontal line of 12. And let's sit here and zoom all day, it looks like. And these never cross. I'll just take a screenshot as is. It's kind of cool and interesting. Looks like no solutions to where these would be equal. These are never equal. Plop that down in here. Now we want the f of x function to be greater than 12, right? We want the downward facing parabola to be greater than 12 to have a solution. And as we look at this, we see that f of x equals negative x squared plus 3x minus 7 is never above g of x equals 12. So there are no solutions. Right? We want to find what x values are there that when we plug them in, the downward facing parabola is greater than 12 for its outputs, and that never happens. There are no solutions to this. No x values result in negative x squared plus 3x minus 7 being bigger than 12. So we can say the solution set is the empty set. Right. Nice job following along there. You guys are awesome. Thanks so much for watching. Go ahead and do the Now You Try problems next. And once you're done with those, then you can check in on the next video where I'll run through the solutions for that. Thank you very much. We'll see you soon.